Hello and welcome in CCIE security course. In these videos we will go through the all subjects of CCIE security, but in a very practical way. You guys will see the commands and the labs that will enable you to understand the concept in a very easy way. I will do my best to make the picture very clear and very simple as well. So let's start with the first subject here, which is VPN Site-to-Site. In order to understand the VPN Site-to-Site, let's understand what is the goal behind VPN Site-to-Site. As you see here in the drawing, we have two locations like that, and these two locations is connected together. We can say this is location. We can say that this is. Actually, we can say that this is location A and this is location P. This two location, what I mean by two location, I mean the two branches. If you have a company, if you are working in a company, and this company has two offices, office A and office B, and these two offices actually has private networks like that, and you need these private networks these two private networks to talk to each other. You may have some users here like that, and these users maybe they are accessing some data here, or there are, for example, there is a database here in this site, and there is an application server here, and this application actually is saving data here on the database. In this aspect, actually, we need in order to connect these two locations together, or in order to be able to make these two private networks connect together, so we need a VPN Site-to-Site. The VPN Site-to-Site is gonna secure my data to be transferred from here to here. And in order to be safely, or in order to safely transfer that data from one side to the other, we need three things. The first one is key. The second one is encryption. The third thing is hashing. These three elements are important for me to transfer the data in a secure way. Here, actually, in order to be able to configure and make the data transfer in a secure way, we need basically the key. The key is very important. The first element here is the key. Okay, when we talk about the key, for example, we have Diffie-Hellman key. The Diffie-Hellman key is generated automatically once you configure it. But actually, I'm gonna face a problem. What is that problem? I'm gonna face a problem actually. What is that problem? In the key itself needs to be encrypted, because if someone in the middle here, if some intruders in the middle, they took the data and they find the key transferred in clear text, that means that someone will use this key to be able to access your data and see your data. So, and from that point, the idea of tunneling or two tunnels be created in the configuration. Actually, I have two phases, two tunnels to be able to configure VPN Site-to-Site. Tunnel A and tunnel phase 1 and phase 2. Phase 1 is gonna encrypt the main key. Here will be the Diffie-Hellman key. That key I'm gonna use it in the phase 2 actually, but in order to be able to use this key in the second phase or in the phase 2, I have to do what actually? I have to encrypt the key itself. So let's make it clear, guys. Okay. So these two tunnels like that will be created in order to get the VPN configured. In order to get the VPN configured, we need these two tunnels. Tunnel 1 we say it phase 1, and tunnel 2 we say it phase 2. Why I need? What is the purpose behind using phase 1 and phase 2? The phase 1 is used to encrypt, to be, actually is gonna be used to encrypt the key. It's called the session key. It's called the session key. Why I do this session key? Why do I need it? The session key. I need the session key to be used in the second phase. To be used in the second phase, actually. So that's why I make the phase 1. Different is the one is creating or generating the key, the session key, different. Okay. This tunnel or phase 1, you can say that we need, in order to transfer the key, we need 3 things: key, encryption, and hashing. The key and encryption and hashing. These 3 things I'm gonna use to encrypt the key, the main key that I am gonna use in the second phase in order to be able to save the main data. What do I mean by the main data? As I draw here the 2 locations, actually, as I said, this is here a private network and here a private network. This is the main data. The main data actually gets encrypted in the second phase. What do I mean? I want to make it more clear. Okay, so phase 1, the purpose of using phase 1 actually is to encrypt the main key. And this main key or the session key, this key is going to be used in a second phase. Why I'm going to use the session key in the second phase? I'm going to use the session key in the second phase to encrypt the data that's going to transfer, the main data that's going to transfer between the 2 sites or between the 2 branches. So that's why, okay, let's write the configuration. And from the configuration itself, it's gonna be familiar and the picture will be visible to you, and it's gonna be very easy for you to understand. So as you see here, my lab, or this is actually the lab I'm gonna use to configure VPN Site-to-Site. Let me explain, or let me make it easy as a lab for you to be able to follow me here. This actually three routers, and these 3 routers are connected. Yani you can say that in the router in the middle, here is expressing, or it's the internet. It is acting as internet. The first router is location 1, and the third router is the location 2 or location P. Now let's go through the configuration, and from the configuration itself, we will step by step understand what is VPN Site-to-Site. In order to configure VPN Site-to-Site, first of all, we need the we need to configure the phase one. We need to configure the phase one. And as I said, the purpose behind using phase one is to encrypt the main key that I'm gonna use. This main key or the session key, that session key, I will use it in the phase two. Why I'm gonna use it in the phase two? I'm gonna use it in the phase two to be able to encrypt that or transfer the data, the main data, in a security way. So as we agreed, first of all, we can say that we need three things to transfer the data in security way. First, we need encryption. Second, we need hashing. Third, we need the key, or the key encryption and hashing. The key. But the key itself has to be transferred in a security way. That's why we use phase one to encrypt the key, which is the main key or the session key that we'll use in a second phase to encrypt the main data. The configuration is as follows. The configuration first of all, or the first thing, is phase one. Phase one. First, you have to configure the phase one. The phase one is crypto ISACAMP policy 10. And under this, we will write authentication, pre-shared, encryption, (3ds), for example, and hash MD5, and group 2. So let's explain this, guys. Let's understand what are these commands actually. I don't know what you are writing right now. So ISACamp, this is a protocol that I'm using here in the phase 1 actually to encrypt the data, and we will understand that later. It developed right now and it became the newer version is ISACamp 2. This is ISACamp 1 actually. What is policy 10? It's a number. It's a number because this number actually you can have on the same router or on the same device. You can have more than one session. Actually, or more than one tunnel. More than one VPN, so you can use multiple sessions. So the second thing is authentication pre-shared key. So okay, so as we agreed that to transfer the Diffie-Hellman key in the phase 1 and to make it securely transferred, we will use that key, we will use the encryption, we will use the hashing. And where is the Diffie-Hellman? Diffie-Hellman is here. Group 2 is gonna generate the Diffie-Hellman password, the Diffie-Hellman key. So I am using these three things: the authentication, the encryption, the hashing, actually to what? To make this key transferred in a secure way. To transfer in a security way, and this key, which is gonna create a group 2, means what? Group 2 is the Diffie-Hellman. Group 1, group 2, group 3, it depends on the length of the key itself. So this is the phase 1. I encrypted the main key that I'm gonna use in the second phase in order to be able to encrypt the main data in the phase 2. The second step, guys, is the what actually? The second step. The second step here is I forgot something here. In the phase 1, you have, as I mentioned here, the key is pre-shared key. So what is the pre-shared key? I have to mention it. So I have to write crypto key, crypto ISACamp, crypto ISACamp key, Cisco, for example, Cisco 123. And what else? I will write the address of the real address of the other site. The real address of the other site. One here, according to my drawing, the other side or the real IP of the other side is what? Is 192.168.20.3. Okay, if suppose that here hypothetically that this is actually which router? This router 1 or location 1. Okay, crypto ISACamp key, Cisco 123 address, the other IP of the other side. Okay, like that. Okay, then what else? The second step, guys, in order to be able to configure the VPN site-to-site, configure the parameters for phase 2. Configure the parameters for phase 2. So phase 2. What should I write for phase 2? Crypto what here? Crypto IP sec transform dash set test test 1, for example, ESP 3DS ESP dash MD5. What is that actually? Here in the phase 1 and phase 2, in a phase 1 as I wrote it as I draw it here. In phase 1 and phase 2 here like that. In phase 1 and phase 2, phase 1 and phase 2. Here is the session key or defilement key, like that, session key, and here's the main data transferred. When I write here crypto key ISACAM transforms it. Here I use ISACAM. I use ISA KMP protocol. Here I use what? I use ESP protocol. ESP protocol. Okay, fine. So this is the second step. This is the second step. The third step, guys. What is the third step? Third step. The third step is define the traffic that will be encrypted over the town. Define the traffic. Here I'm gonna define the traffic. How I'm gonna define the traffic here? Actually, the traffic the traffic here it called interested traffic, and in order to define it, I need ACL, access list. I need access list, like that. Access list dash list 101 permit 10 dot what actually, and that side I have 10.1.1.1.0. To go to what? To go to 10.3.3.3, which is the other side. This is actually the private network. This is actually the private network that I was talking about, that these two private networks want to talk to each other through the public network or through the internet. So this is the interested traffic that needs to talk to each other. And as per MyLab here is one in that location, and in that location here is 10.3.3.0. Like that. So this is interested traffic. This is actually the main data that I'm gonna encrypt in phase 2. What is the next step after that? Configure a crypto map to link to the above parameters to each other. Configure a crypto map link. Yeah. Here I have to configure crypto map, and I'm gonna give it any name, C map for example. Give it a number. IBSIC ISACAM. Crypto map CMAP 5 IBSIC ISACAM. Here's what actually in that mapping, or in that crypto map I'm gonna do what? Match the interesting traffic, match address 101, and do what else? Set peer. What is the IP address of the other side? as I told you, I'm working here on that router 1 or the branch A, branch 1. Set the peer, the public IP of the other side 192.168.20.3. This is the peer. And set transform set transform set transform set t set 2. No, t set 1 here, because actually here in CryptoMap, what I did in CryptoMap, I already gathered all the elements or all the parts together. It means that I connected everything together now. The interested traffic, the peer, which is the other side, and the transform set, which is what? The transform set is the second phase that I will use to encrypt the main data. This is a step number. This is step number 4. If I give it number, this is phase number 1. This is step number 1. This is step number 2. Step number 3, and step number 4. You can say this is step number 4. CryptoMap. Step number 5 is to implement it on the interface, outgoing interface. Implement on the outgoing interface. That's good. So let's implement it, guys. Interface. I'm gonna use which interface? I will use this interface, which is outgoing interface, which is gig interface gig 0 0, and I will write what actually CryptoMap CMap. Crypto map CMap. Here, the name of the map itself, the crypto map. By that, I finished the first site. The second site, or you can take this copy like that and write it here. It will be router 3. It will be router 3. Phase 1, there is no any change. Here I have to write the other IP, which is 10.1. That side, actually, this is the IP of that side. And here in the access list, I have to flip it. I have to flip it. Like that. And here set the peer to .10.1. I can use the same number. Yeah. It's locally significant actually. And here the interface is 0 1. Okay, so let's go and do this configuration on router 1. The first phase, copy to router 1. Yeah, like that. Okay, this is phase 1. Phase 2, yeah, the key. Crypto. Let's make it here. Crypto. Like that. And should be like that actually. Phase 2. This is phase 2. Can make it like that too. Not giving any error. Let's see why. Access list. Yeah, here is one. Oh, sorry. Dot, and here 0 dot, like that. Oh, sorry. Let's write it in the proper way. Oh, sorry, guys. Here I have to write what? I have to write IP. 0.0.0.255 10.330.0.0.0.255. Now step number 4, which is crypto map. Yes. And the interface itself. I'm gonna this is step number 5. I'm gonna implement on the interface gig 0/0 crypto map cmap. Exit one more time. Show IP interface brief. Here is my interface. Okay, so we will go to the other side, which is router 3. On router 3, phase 1, key encryption and hashing. Same issue here. Pressure key. This is the second step. And third step is phase 2. Oh, this is the second step actually. Third, interesting traffic. Here, right, IP. What? Oh, sorry. Permit IP. Let's write it. Access list 101. Permit IP. Let's remove the IP. Access list 101, permit IP, and as you see, it's working. So the fourth step is the crypto map. And as I told you, the crypto map is to gathering everything together, the all parts together. And what is the interface here? Show IP interface pref. The interface that connect me to the other side is 01. So conft interface gig 01 enter. Then I'll write crypto map C map. Even this actually, this names is locally significant, guys. Yeah, so you can give any name actually, but it should be relate. If you give this name, you have to, yeah, in this step number 4, in the crypto map, you have to give a name. It doesn't. It's not necessary to be the same as it is in the other side or at the other end. Right. Actually, to verify, show crypto SA show crypto ISACAMP SA. SA is for session association. You will find nothing actually. Why I'm find nothing? Because there is no data until now. There is no data go through the tunnel. So what should I do here? I should bing the other side. Bing 10 dot the other side 333, and source is what? Source is 10.1.1.1, like that. Show crypto Isacamp SA. As you see here, it start working actually. It encrypted here is telling you what is the source and what is the destination. And idle here, sir. So let's tell you, or let's explain you what is the meaning of idle here. The idle means it's working perfectly. It's working perfectly. This is the destination, so it's working perfectly. Why? Because guys, you know, I'm gonna explain it to you. In phase one, it's 600 second. This is actually the lifetime of the session, and the lifetime of the second session, the lifetime of the session key is 3600 second. What does it mean actually? The Diffie-Hellman is correct, or it's generating the keys, or generating the password, or generating the key that I'm gonna use in the phase 2. Actually, 36 seconds is 1 hour. Is 1 hour. Diffie-Hellman is gonna be the lifetime of that key is 1 hour. So each 1 hour, it's creating, it's waking up, creating a key, then it sleep again. It become idle again. So each hour, the Diffie-Hellman, so each 1 hour, it's creating or generating a key. That's why here it's giving me the idle status here. There is one more verification command, which is show crypto IPsec SA. Here it's gonna show you the packets actually that encrypted, and here is actually the key that generated by that Diffie-Hellman group. Okay guys, and by that we finish the first lesson. See you in the second lesson.